Hello and welcome to SmartTALK. I'm Craig Eason from Fathom World. Vessel performance is a key parameter in today's focused maritime industry, and having the right tools to both measure performance and then to make improvements across a vessel's operational life or across a company's fleet is big business. This SmartTALK, brought in partnership with our sponsor Jotun, aims to look at how a set of recently introduced standards for measuring performance are being used. The 2016 standard ISO 19030 gives a way for industry to measure changes in hull and propeller performance in particular. We have a panel of 3 experts to look at how the standard is being used to give the industry a direction in improving performance. First, Jotun's Tom Everson will look at the ISO standard from the coating manufacturer's point of view. What has the standard been set up to achieve, and how can owners use it with the tools at their disposal to accurately measure the link between hull, speed and fuel consumption?
The standard as such consists of 3 parts, where part 1 covers general principles, part 2 describes the default method, which is based on high frequency data resolution with a very high accuracy, and lastly part 3, which basically covers any other alternative method. It goes without saying that there's different levels of accuracy associated with the various approaches, and for some a lower accuracy might be good enough, while depending on intentions and expected outcome, a higher level of accuracy might be required in other cases. The required components cover equipment which is predominantly already installed on most modern vessels. One would need some sort of data logging unit, GPS, which is mandatory on vessels, a Doppler log for measuring speed through water, in addition to a torque meter, a draft meter or some sort of onboard loading computer, and then anemometer for wind speed and direction. So the ISO 19030 standard describes in detail 4 different KPIs. Firstly, it describes the dry docking effects, and this is, for instance, a comparison of 2 different pretreatments when conducting a dry dock. So typically touch-up versus full blast and so on. The second KPI describes the in-service performance, where one monitors the vessel's hull and propeller performance over time as compared to a benchmark, which is set for the first year out of dock or after new build delivery, and then subsequently one monitors then over time as compared to this benchmark year. The third KPI describes maintenance triggers, which would be used to, for instance, determine when a hull cleaning shall be initiated. The fourth KPI describes the effects of maintenance conducted, such as hull and or propeller cleanings, or the effects of a dry docking. Now let's put these KPIs into a practical example. So this is the performance plot as per ISO 19030-2 for a reference vessels. Filter criteria have been applied, and every plot represents the average daily value. Now we know for a fact that a dry docking took place in July 2014, and having reviewed the operational data of the vessel in questions, we know that she had a prolonged idling period in October 2012. Having the high resolution data available enables us to quantify the consequences of this event, expressed in this case as a significant drop in speed. Due to poor hull and propeller performance, the vessel's hull was cleaned in May 2013, and we're able to clearly see the effects of this hull cleaning. Now, applying the second KPI, the in-service performance monitoring, we have in this case averaged the performance in the first year after dry docking as according to the standard, and then this represents our reference period. And then over the subsequent years after this reference period, which is then known as the evaluation period, we disclose the level of hull and propeller performance over time. This standard also enables us to compare two docking periods, and in this case we have seen a significant difference between the two periods in question. Now, the relative difference in speed loss between these two periods is in the range of 7 percentage points, which is equivalent to a difference in energy efficiency of more than 20%. So a quite staggering difference in performance of these two dry docking periods. Now, comparing the absolute performance level out of dock, we can then actually disclose the difference in performance associated with, amongst others, different pre-treatments. And in this case, we know a spot blast was conducted at the first dry docking, while a full blast was conducted at the second dry docking. And the difference in performance level is in the range of 5 percentage points when it comes to speed. And in this case, this would be equivalent to an energy efficiency gain of a staggering 15%, associated in this case to the pre-treatment in dry docking foremost. Now, Jotun believes that the establishment of the ISO 19030 standard and subsequent widespread adoption of this standards would enable the industry to take better decisions. It will lead to an increased transparency throughout the industry and also a closer alignment of stakeholders' incentives. It appears reasonable to argue that ISO 19030 will enable quantifiable reductions in both energy cost and subsequently greenhouse gas emissions.
Tom Everson from Jotun, supporter of this SmartTALK episode. Later, during SmartTALK, we'll hear from Mauricio D'Amico from the ship owner D'Amico Shipping about his experiences in measuring vessel performance. Also, now is a good time to remind you that you can use the comments tabs to ask questions of the webinar participants or of other viewers that are online today. This ISO standard was developed over a number of years and was the work of collaboration between otherwise competitive hull coatings makers, performance software companies, ship owners, and the class societies. DNVGL's Daniel Schmoder is a vessel hydrodynamics, data analytics, and performance expert. Here he talks about how the performance standards are a step in the right direction, but more can be done.
Objective of ISO 19030 is to recommend a practical method for measuring changes in hydrodynamic performance. Our customers ask us also to provide a method that works for vessels that do not have an autologger, which is 80% of the world fleet, and to predict the absolute level of hydrodynamic performance, and not only the changes. In the following, I'll show you how we achieve these objectives. First thing is that the weather corrections recommended by the ISO are too large. So we overcorrect for the weather, which is introducing scatter and also spoils the level of the performance index. So we use our database of 2,000 plus vessels to derive better data-driven wind coefficients, which we then apply. Second point is that fouling only affects viscous resistance, not the pressure resistance. So we reformulated the performance index to take into account only the viscous increase in power. Talking about viscosity, also the water temperature has an effect on the viscous resistance and needs to be corrected, which can be easily done when the water temperature is recorded, which we do. And important point to work with low frequency data is the filtering. The ISO recommended filter is quite simple. It just looks into the wind speed. But we see data sets where 90% of the data is filtered out by this quite strict wind filter. So we developed a more targeted filter that ensures that the contribution of the weather correction is not above a certain limit. And by using this smart filter, which takes into account wind direction, wind speed, vessel geometry, vessel speed, and other parameters, we have more raw data points surviving the filtering process, and that enables us to work also with low frequency data sets. And finally, we still see some systematic biases in the dataset, which we can correct based on machine learning methods. So we identify these biases with modern algorithms and correct for these biases. And by doing so, for example, the index is less dependent on vessel speed. Let's look into some examples. Here we have a data set where in the middle we have a painting event. In the first period we see sparse data. The ISO filter filtered out most of the raw data, and yeah, we see that putting a regression line gives us an implausible slope here. After the docking, the performance goes up, but only to 90%, which is below expectation. Applying the eco-insight method, we see that we have more data surviving the filtering, and we have a plausible slope in the first period. And after the dry docking, performance goes up to 97%, which is more the expected value. Let's look into a second data set. This is manually reported data. So the crew has done what we call snapshot reporting. So they took 15 minutes averages of speed through water, power, and the weather conditions and reported these data. And based on these data, we evaluated the ISO method and get this picture. So again, data is quite sparse. We call this several years of data here. And after the docking, the performance goes up to 80%, below expectation. So applying the new method, more data survives the filtering process, and the performance after applying the new paint goes up to 96%, which is the expected value. So summarizing, our method provides accurate results, also on low frequency manual reported data, so no need for an autologger to do hull performance prediction. It allows us to predict the absolute level. It reduces dependencies on operational profile, and it is still compliant to ISO 19030.
That's Daniel Shimoda from DNVGL. In the second part of this Smart Talk, I'll be asking Maurizio D'Amico from D'Amico Shipping in Italy about his experiences as a ship owner using the standards to help in operational decision making, and asking what else needs to be done to improve the data and thus performance. Now we're into the second part of this webinar today, and I'm going to introduce Maurizio D'Amico from D'Amico Shipping. Maurizio, from your perspective, you've got a number of vessels that you operate. I wonder if you could just give us some examples from your point of view as a ship owner and operator in terms of using performance standards like this ISO 19030 in your drive to increase operational performance.
Yeah, good morning, everybody. Thank you for the opportunity to give my comments. Yeah, basically the process started some time ago, and now is operational across the fleet, particularly on the, as you can imagine, on the new buildings. So, what to say? There is a need. You have to consider the time. It's not so easy to change the setup on board the vessel, and to fine-tune all the equipments which are involved. So this has to be taken in consideration. Secondly, at a central in the fleet department, once you put up your ship performance department, then again, really you cannot buy only external intelligence and put simply into your own organization. And very much depends on the kind of fleet we are talking about, if are bulk carrier, tankers or containers. They all have a different necessity. It depends very much on your customer and the interaction with your customer. So for a tanker, for example, there are some contractual restraints. On a bulk carrier, it's a different situation.
So when you talk about the contractual constraints, do you mean like with the charter parties in terms of what you're able to do under a charter party?
Correct.
And is there a drive though within the industry? I've seen various corners of the industry talk about this, the issue of the charter party being a bit of a hindrance in terms of driving performance within the sector. Has there not been a lot of work in creating clauses for charter parties, in having customers be more aware of the need for performance and being a bit more engaged in that discussion?
Yeah, surprisingly, on the bulk carrier side, we are having a sort of a drive, as you call it. The speed, the push ahead is much faster. They already understood our counterparts, the situations, and therefore we have some parameters which are already built in the clauses. On the tanker side, for obvious reason, it still takes a little bit of time before all parties can reach an agreement.
And therefore, you need to have a lot more sort of discussion. Do you think that the charterers need to be a lot more aware of the operational parameters of a ship? There's a question that's just come in relating to the route being against the current. If you've got currents that counter the effect on the route, the route alignment. Is that an issue? Is that one of those topics that could actually be creating a sort of a problem?
Yeah, I confirm you touched immediately the core, one of the core of the parameters to be addressed. You know, we also come from tradition, and we are years and years of a relationship between the owners and the charters. Therefore, we start already from a long story of relationship where basically, you know, in the past was an averaging of an average vessel of an average voyage. Before, traditionally, because there was less sensitivity on consumption, on the environmental impact and emissions. You know, this was very much left to the single owner to incorporate in his business model all the weather conditions, the impact of the current. Therefore, now that we have all the terabytes we are receiving on a 5 minute scatter, we have all the real situation of the weather conditions, which was not the case in the past. Yeah, now we have the data, and now we are in a position to be much more clear among each other. Also, if the operator is always retaining, let's say, a touch on the operational reality of the vessel, but also from a charter side, now they have the data, and now it is easier, maybe will be easier for us as operator to sit down and face the reality of a single voyage.
How do you go about when you're talking about the data? And I'm going to go back to one of the earlier questions that came in from viewers for this webinar, and that's about baselining, about actually having a baseline when you're looking at. The question was relating to retrofitting vessels with new technologies or new measurement systems. But do you know, generally, how do you baseline your performance? Do you use the exactly as the vessel comes out of dry dock with a new coating? Would that be your baseline?
Yeah, I cannot go into all the details on retrofitting. I'm not an expert. Basically, you touched really, for what we can see, the core of the problem. Now, if for the moment we come out from a situation of as built a new building vessel or as an existing vessel. It doesn't matter very much. Let's say if we're speaking just as an example for a new building, you touched really what is the core of the discussion of today. We are giving for granted that the quality of the sea trial diagram, which is a contractual situation to accept the vessel, is the baseline which is useful for operational measurement during the real life of a vessel, but it is not. As operators, we really can see more on the bulk carrier side, less on the tanker, but regardless of the kind of a vessel, we have built many different type of vessel in different countries. It all comes out always the same kind of reality. But we apart the towing tanks experience and the various measurement we can do at a design stage, when we do the sea trials, and I was very surprised from the admittance from Daniel from the NVGL that he, as a first key point, set it up that they are overcorrected the sea trial. So again, now is official. What we have had as a feeling, much more must be done apart the contractual parameters to accept the vessel. Much more has to be done at the sea trial level to understand at a different draft, at a different direction from the wind, the sensibility of the data, how really the performance of the single vessel comes out. This is so important. So I recommend as a baseline to be careful, to study really the situation of a model when you take a vessel. Maybe you can do a baseline based on the, let's say, on the first year of data collection. And from there you can have some indication at a different draft, at a different direction of the wind, at a different sea state.
I think one of the problems with the sea trials is that this is actually it's like proving the new building contract between the ship owner and the shipyard that the vessel has been built and is operating according to the contract that was signed. You know, the performance of the vessel, the consumption of the vessel based on the engine parameters. But what we're talking about here is something relating to performance of the vessel subsequently, and therefore sort of the measurement parameters maybe need to be slightly different.
Correct. If you can imagine that the contractual draft that you are using at the sea, just as an example, just to give an example, what you are using at the sea trial, let's say for a bulk carrier, is very, very far away from the first draft the vessel will be operated at the first voyage. Therefore, the correction you have to do, particularly, let's say, as an example, for a bulk carrier, the correction that you have to do between the actual draft at the sea trial and the maximum deadweight where you can operate is quite a big factor. And also, it has been said in the slide that the correction for the wind is overestimating and is an overcorrection. So therefore, there is, in my opinion, a need apart for the acceptance of the vessel to better understand the reality. So once the vessel is accepted, the reality of on how you can use the vessel at a different draft, as I said, at a different speed. In my opinion, we have to now that we have the real data, we can sort of back up, go back to the designer, go back to the contractual clauses, and be a little bit more accurate. This, in my opinion, some work can be done at various levels. This is my personal opinion.
Let me bring in Tom and Daniel here back into this conversation now. Let's start with Daniel Schmolder from DNVGL. When we're talking about the performance data, or what you were saying during your presentation, Daniel, do you think that we are, you kind of alluded to the fact, and Maurizio said here, that we are overcompensating in terms of the performance? Is it that we're doing too much, and therefore that the performance standards that we have do need to be reassessed, basically, that the ISO standard needs to be reassessed in due course?
Yeah, thanks for the question. Hello, everybody. First of all, I think the ISO method is a very, very good baseline to measure these things. No? So we can see quite a lot by applying the ISO standard method part 2. But yeah, you're right, as you said, for example, the weather is overcorrected. And we see actually that when the vessel sees harsh winds, the performance index shows a better high performance, which can't be. High performance will not change from one day to another. But when the wind changes from one day to another, we see that the high performance changes, and that could be improved. Today, we have a lot of data. We have 2,000 vessels in our database, and we see daily reports from them, and we can easily identify these gaps in the coefficients from the literature and in the real coefficients, and yeah, we can further develop ISO and further develop the corrections which are used when doing high performance monitoring. Right.
There's a question here in terms of being able to determine empirically and separate the propeller and the hull fouling. Is that something that can be done? I'm not sure. I think perhaps I'll ask Tom this. Tom, from your perspective, is it possible to separate propeller and hull fouling and see therefore what needs to be done? Or is it a case that needs to be achieved through data measurement and then visual inspection?
It's a very good question, and it's a question which comes up in, I would say, 8 out of 10 customer meetings I attend, where we discuss measurability and standards and so forth. We were always being approached with, are we able to separate hull and propeller performance? And in theory, and I'm sure Daniel can back me on this, if you would measure torque and thrust, you would then be able to completely separate hull and propeller performance. Now, the accuracy of thrust measurement equipment has been a main issue here. Vibration, temperature, and so forth plays into role. And we are looking at like fairly low numbers, which would trigger when to initiate a propeller cleaning, for instance. So simply the stat on accuracy and data collection has not made this efficiency yet. But there are makers of thrust meters that claim that the equipment available in today's market with new technology using optical reading rather than different approaches and so forth has increased the measurability and accuracy significantly, and therefore you should in theory be able to do so. From a practical point of view, my personal recommendation would be that if you have adopted ISO 19030, you're looking at hull and propeller performance as one. You would basically do a visual assessment. So it means a quick dive inspection when possible to see is it propeller which is fault or hull or both. Another option which has popped up, I would say in the past couple of years, is actually ROV technology. I mean, you can buy an off-the-shelf high-end ROV for roughly $5,000. And having such a device on board, gives you a huge flexibility in terms of doing hull and propeller assessments in case of eventualities, in case you have ropes and other things entangled in your propeller, if you hit something during a voyage, or if you simply want to do an assessment on rudder, propeller, anodes, and so forth. You can actually do this on the spot with fairly
low-cost equipment, and that would be a good supplement in addition to having data collection.
So you would be able to sort of increase the performance of the vessel, but by actually putting the ROV, there must be limitations in how and when you can put an ROV in the water.
Oh, absolutely.
Whether the crew
Absolutely.
would be able to do that. I just wanted to, there's another question that came in, and it was touched on earlier by Maurizio and through the presentations. But Tom, when it comes to the amount of data that's collected, if you've got too little data or it's sparse, then you've got the question of how accurate the graph is that you're going to, the picture you're going to build. And if you get too much data, it might be too much clutter, effectively.
Yeah.
And when I was looking at your graphs on your presentation, personally, I could take a line and put it almost anywhere. Okay, I'm only taking eye contact of that graph. I'm not taking any empirical decision there. But when you determine which line you're going to use, it just seems sometimes that it looks like it could be one line or another line quite easily. How do you know that the performance line that you're drawing on that graph actually reflects the proper performance? Because Daniel went on to say you could actually find another line quite easily if you looked at the data differently.
Absolutely. And again, in us, paint industry, and also being part in the ISO working group, we're being challenged in this, and there has been no claims that ISO 19030 is perfect or flawless or has its weaknesses, but it represents a fantastic starting point in order to move the industry forward. And I think we need to take one step back, actually. You need to first, which is something that Maurizio touched upon, first you need to do an assessment on why do I need data collection? What are these results going to give me? Do I simply want to know if hull and propeller performance is dropping, and should I inspect the hull and maybe do a hull cleaning? That's one scenario. Another one is the under a contractual agreement, charter party agreements, technology suppliers, typically a supplier of Mavis ducts, Boss Cap fins, Vortex fins, giving you promises of 3 to 5% fuel saving and so forth. Then obviously you would require a somewhat higher level of accuracy when you go into these contractual agreements. So the first thing you need to disclose is, where do I want to go with the data? What kind of results am I aiming for? And then obviously in some cases you can actually deal with a situation where you have, let's say, an indication rather than a scientific evidence or proof that something has changed. From a paint maker's perspective, we're obviously interested in the development of performance related to the anti-fouling system on the hull. And once you have the anti-fouling system on, you have all the time in the world. I mean, on modern vessels, it's there for 5 full years. There's very little you can do. You could theoretically redock the vessel, blast the dam system off and replace it with another one, but it's very, very rarely done. So hull cleanings and some sort of hull maintenance would be the case in terms of performance drop. So for us, if we're not under some sort of cashback contractual agreement, we can live with the fact that we have rather an indication on development of hull performance, rather than having absolutely nothing and being completely blind. And I think this is the first thing one needs to discuss. What do you want to achieve with the analysis and the data collection?
Let me just put that question then back towards Maurizio. Maurizio, from your perspective then, what do you want to achieve from the data collection and looking at the performance of the vessels? Do you want to use it as a part of the conversation with charterers, or do you need it as part of your discussion with your service providers, hull coatings manufacturers and other equipment makers?
Yeah, the first step is to analyze the total fuel consumption of a voyage, the stock, the specific fuel oil consumption, and this is the first step to understand, because this is money, regardless if it's money spent from your customer or from yourself, it doesn't matter. We are speaking about the consumption performance of your fleet. Therefore, we have to be accountable for that. So this is the first step. Then you have to, let's say, interact between this data and your contractual constraint. This is a very important step, and this is again a target we have to achieve. Done that, then you analyze and you find out that we are doing it monthly in our fleet database internally, and we can spot each vessel, the one who are above or are under the baseline. So then you can concentrate your attention to the one who are underperforming. And this is the moment where internally you have to further, if I may add a parameter to the discussion we have done this morning, it's so important once you consider the specific fuel oil consumption to understand that two different vessels, exactly same, built in the same yard, but on different routes, particularly, let's say, having a different maintenance story, they can give two different for specific consumption due to the mechanical situation of the maintenance of the single main engine. This is something also is an important indication on how you run your main engine. Even another factor can be how good a master can follow the routing of the vessel in terms of trim, in terms of steering.
So really, there's a lot of different factors that can come into that picture when you evolve you use the data and evolve your thinking behind that. But there's a difference between data and action. So how do you go about looking at the data and then turning it into some actionable change within your organization? How do you actually look at the data and then say, right, we're going to implement change? I'm just curious how you actually look at information like performance data of a fleet and then assess what it is you need to do and then implement it.
Yeah, we plot also how many days the vessel is at anchor or stopped in some area. This is also a factor to be in consideration. Before then we take the decision, and this is continuous, either to have the polishing of the propeller or both, or to clean the hull in order to regain the propulsion parameters. This is something which we are doing. This is the actions we are doing and are giving a very good result. Not all the area is easy to perform hull cleaning, but it gives a very good result, generally speaking. So the actions are always that. It's something different is to take the decision when to dry dock. This is a little bit more complex, because to stop or to ask authorization once the vessel is at anchor to have the hull cleaned is something which can be arranged with no big complexity. It is different to plan the dry docking of a vessel, as you can imagine. There are other factors coming in, the area of trade, the availability of a dry dock, so the opportunity to send the spare parts to optimize the maintenance. So therefore, the actions for stop the vessel and put it in dry dock and have it painted again is a bigger reasoning internally.
So really, it comes down to even the sort of the selection of the dry dock can actually impact the performance of the vessel. Does that mean, Tom? Can I ask this question of you then? Does how coatings are applied onto the hull, is that impacted by the quality of the dry dock that is actually applying the hull coating?
To a large extent. I mean, having dug into the very interesting field of hull and propeller performance, we also initiated a separate program where we basically try to log everything. And one of the KPIs that we have in terms of determining whether a dry docking has been, let's say, successfully or not so successfully, is conducting average hull roughness measurements. And by now we have done this over more than 7 years on a high number of vessels, and we can also already see some quite interesting trends. We can see differences in seasonal variancy. So winter application is obviously tougher for us paint makers than when you have a warmer climate in terms of drying time and viscosity of the paint and so forth. We have seen huge variations in yard-specific results. So everybody who's been up the Yangtze knows there's a huge range in going from high-end yards in association sometimes with Japanese companies and so forth to yards which we've classified maybe not so good. So there's quite a bit of difference there. And then obviously the underlying substrate, the physical roughness, which would come if you're doing a touch-up, come from edges and squaring and dents and all kinds of welding seams, everything which would be classified as physical roughness, underlying roughness, which is there regardless. There's then a very big difference between conducting a touch-ups or going down to bare steel and conducting a SA2 or SA2.5 full blast. And then having data from a vast range of vessels, we have seen typically that just simply docking a vessel and doing some pre-treatment, so cleaning the hull, applying fresh paint and so forth, gives you an ultimate performance gain. And it has very little to do with the paint which is applied. It has to do with the fact that the hull has been cleaned and you have done some sort of pre-treatment. But we see typically a speed gain in the range of 5 to 12% on vessels where you have done a touch-up. And we see a performance gain in the range of 10 to 17% in speeds related to if you do a full blast. And this would then also then give you proof that the better the pre-treatment, the better the out-of-dock performance. But again, at the end of the day, it's going to be vessel specific. If your performance is really, really poor going into dock, there's a huge potential for an increase in performance. If the hull is more or less clean when you come into dock, there's obviously a quite significantly reduced performance gain to be obtained. Thanks.
Let me take that, Tom. Let me take that one step further then and ask Daniel here, because there's another question here. The ultimate goal is to save fuel, but when comparing a ship's performance over two separate voyages, how can you determine the root cause of lower performance? Without effective fuel flow metering, it could be entirely down to hidden current and the hull propeller, while the hull propeller could be fine. So how do you drill down? How are you able to drill down and actually determine the lower performance? And the question was relating there to two different voyages, but I would say over the whole span between two dry dockings, how do you determine the real cause using the data that's available?
That's a good question, and it, as you mentioned, depends on the data available. For example, if it's a matter of current or not, we check by looking at speed through water and speed over ground, then we see much current, and fuel consumption or required propulsion power should always be compared checking the speed through water. No, that's the hydrodynamic interesting part. That's one part, and there are many other things that we check. We look into the trim, we look into the main engine performance, so we check the SFOC, and we look into the weather, wind direction is important, also loading condition, type of vessel. There are many parameters that need to be checked. And what we do, we derive complex KPIs based on the different physical effects, and then we check the data and can give you an indication if it's a matter of the main engine or if it's a matter of the hull. That's what we do.
Yeah. Maurizio, how do you see the ability to actually determine the root cause of any degradation in performance?
When you have, let's say, 2-3 people in your performance department and let's say 10 or 20 vessels to be analyzed, they can be done manually. Once you grow in the fleet size, then my comment will be that there must be some assistance from, let's say, an artificial intelligence, which is already there, is only to be tested a little bit and to be optimized, so that the first data filtering, the first real analysis from the terabytes you are receiving continuously from the fleet can be, let's say, pre-analyzed. And then it comes to the specialist to interpret the result from this intelligence, artificial intelligence, and validate or recommendation to go on board and double check something or reanalyze the real performance of that single voyage or these bunches of voyages which are giving surprise from the expected performance.